Hi everyone. So let's talk about the shortest unsorted continuous subarray. So you're given an array and you need to find out the continuous subarray, let if only if you sort it. So which means we want to find out the subarray which is unsorted in the unsorted array, right? So we can sort. Alright. So let me try to draw the picture. I'm going to talk about a logic and then you'll be able to understand what happened. So this is the array 2, 6, 4, 8, 10, 9, 15. Right? So the sorted array is going to be what? 2, 4, 6, 8, 9, 10, and 15, right? So again, this is pretty straightforward. We can use our eyes to check from here to here. You're sorted, right? And 2 and 15 is already sorted, so we don't want to move again. But from 4 to 10, you actually need to sort it, right? So this is then of 5, right? So the problem is how do you code this stuff? So there are many ways you can use brute force, but I don't recommend you to do this. But this is solvable for sure. But I'm going to teach you about a quicker way. So you are using the 2-pointer, and basically you want to assume. So for first pointer, I'm going to call min, and then second pointer, I'm going to call max. So you can say I and j doesn't matter, but I would like to use min and max in this example. So I would have to compare your neighbor, starting from index 1 to the end, right? So I would say I with I minus 1, you have to compare. So since we are update our mean, so if this is ascending order, right? So we go from left to right. So from left to right, this is ascending order, right? So we want to find out if there is a descending pair in the ascending order, then we need to update the current mean, right? So 2 to 6 is ascending order, right? So we don't have to worry about this. Okay, this is data color. So 6 to 4. 6 to 4 is what? Descending order. And then we are in the ascending order, and then we find out the descending order pair in the ascending order, right? So we will pull out the 4, right? Pull out the 4 to mean, and keep going. 4 and 8, right? 4 and 8, which is ascending order. We don't want to pull out anything. And 8 and 10, this is what? Ascending order, right? So we don't want to touch anything. 10 and 9, this is what? Descending pair, right? So we will pull out 9 to the mean. So we will keep updating. What is the current mean in the unsorted array, right? So I would say 4, 9, something like this, right? So this is definitely 4, right? 9 and 15 is what you don't touch, right? But let me move on the next pointer. So for the next pointer, I'm starting from here all the way to the beginning, right? And then we compare what? We compare j comma j plus 1. So this is a pair, right? We're starting from here, right? So this is a pair. We want to for right to left, right? This is what? Descending order, right? And then if there is ascending pair in the descending order, then we will put all the value and then keep updating our max, right? So let me move on. 9 and 15. Well, this is descending order, so we don't touch anything, right? So we move the pointer to here. 10 and 9, 10 and 9, right? 10 and 9 is what? It's ascending order, right? But we are in descending order comparison. So we'll update what? We'll update 10, right? So 10 and something, and then you keep comparing. 10 and 8, descending order, don't touch anything. 8 and 4, descending order, we don't touch anything. But 6 and 4, this is ascending order, right? So we'll compare with 6. And 6 and 2, descending order, so this is it, right? So what is the current min and current max? So this is going to be what? This is going to be conclude to 10. This is going to be conclude to 4, right? Alright, now we know what is the minimum and maximum when we find out the unsorted array. Then we can actually know how do we find out the index, right? So again, you still need to traverse again from left to right, and right to left. So let me start for left to right. So for the mean, we know it's 4, right? So we compare the value. Is this value greater than the 4, right? If this is true, then we know the index value is wrong. It's definitely wrong, right? So 2 and 4, right? This statement doesn't work, right? 6 and 4, right? 6 is greater than 4. So this index, we will remember this index, right? So now we know, like, we break out the traversal for left to right, because we already know this is unsorted subarray, and then we will find out the maximum index later on, right? So let me try to find out this one. So from left to right, we start from the end to just compare. Is the 15? It's the current value. Sorry, it's the current value, which is what, greater, less than the max. Sorry, I was saying wrong, right? If this is less than max, max is 10, right? If this value is less than max, then we will stop traversal from left, from right to left, right? So 15 and 10, this is not comparable, right? So 9 and 10, 9 is definitely less than 10, right? So we will stop at this index. Oh my god, what I'm doing? Stop at this index. Now we have 2 pointer, right? So we can calculate the length right away, right? So this is gonna be what? 0, 1, 2, 3, 4, 5. 5 minus 1 plus 1, because we start from base index 0, right? So we need a plus 1. So the answer is 5, right? And again, if the pointer, if the left pointer, I'm going to call I, this is going to call j, so it's going to be j minus I plus 1. If I is greater than j, so which means like I something, I is over here, and then j is over here, right? So you cross each other, so you will basically return 0, because this is already found, is sorted, right? So let me stop for it, and then I talk a lot, whatever, right? So I'm going to have a mean and a max, right? Max. So my mean is equal to what? I'm going to assume there's an infinite, right? And then my max, there is a still infinite, but it's negative infinite number. And I'm going to just keep comparing, right? So for in I one number, then it's I plus x. If number I less than number I minus 1, right? So I and I minus 1. If this is what? If you break out the ascending order, this is what, descending. This is descending too, right? Something like this, right? You just update mean equal to max of mean comma number I, right? Again, traversing again from right to left. So I'm going to say this is, so it was supposed to be minus 1, right? But we need to compare as a pair, so we need to just say minus 2 related to minus 1. So this is descending pair, and then we want to find out if there is ascending. Ascending here in the descending order. So you will say max equal to max of max. And max, come on, number j, right? I'm going to traverse again to find out what exactly the mean value index, right? So for int, and I mean I'm going to using my I, right? So I less nums so I'm going to say if numset I is greater than mean, I will break, right? And in j equal to what? Number length minus 1, starting from the last index, comma j greater equal to 0, j minus minus, and then find out if the number j is less than max, you break. And then your return based on the if statement, if I greater than j, right, you return 0, which is already comparable. So j minus I plus 5. Alright, so I don't care if I have typo or not. I'm gonna fix. Yes, I do. Okay, I do have typo. I'm gonna just auto check again. Alright, so let me submit. Alright, pass the test. So let's talk about the time and space. This is going to be a time, this is going to be a time, and this is going to be time. So what is the maximum, the worst case? This is going to be all of n, right? This is going to be all of n. So the worst case is all of n for the time. The space is constant, right? Constant. This is constant. So space is all of 1, time is, time is all of n. And this is the solution, and I will see you next time. Bye.